Welcome to the FFMPEG School of Assembly Language, where we're about to embark on an exciting journey into the world of programming. Today's discussion is all about assembly language, what it is, why it matters, and how it brings the magic behind the scenes of multimedia processing. Let's start with a foundational question. What exactly is assembly language? Well, imagine it as a whispering bridge between humans and machines. Assembly language allows programmers to write code that is directly understood by a CPU. This code is then transformed into machine code, binary data that the computer can process. Fascinating, right? You might hear it referred to as ASM, and it's particularly special in FFmpeg. Now, if you've ever heard of SIMD, or single instruction multiple data, you'll know it's a big deal in assembly language programming. Picture this. Instead of performing operations individually on data elements, like adding two numbers at a time, SIMD lets us tackle multiple elements simultaneously. This is especially useful for tasks like video and audio processing, which involve troves of data locked in memory. This brings us to what we aim for when writing in assembly language: speed. Assembly code can turbocharge multimedia processing. Imagine achieving a 10x speed boost. That's a game changer, especially when you're watching your favorite movie or streaming music, and you definitely don't want stuttering. But did you know that even high school students have crafted assembly code for FFmpeg? It's true. Learning this language can be daunting, but much of it is about grasping the jargon and tackling the challenge head-on. Assembly is not just for seasoned pros. It's within reach for anyone willing to learn. Now, let's chat a bit about why we might choose to write in assembly instead of relying on higher-level languages. You'll come across discussions about using intrinsics, C-like functions that align closely with assembly instructions. There's a debate here for sure. While intrinsics can speed up development, they're often less efficient than handwritten assembly, which is the route we take in FFmpeg. Speaking of techniques, we're focusing on x86 64-bit assembly language, specifically using Intel syntax. Think of it as our toolkit. There are also other assembly languages out there for different CPUs, like ARM and RISC-V, but for now, we're diving into the intricacies of x86 assembly. As we venture deeper, you'll likely encounter the concept of registers. These are the little workhorses within the CPU, where data is temporarily held and processed. General-purpose registers, or GPRs, can handle either data values or memory addresses. It's like having a desk with multiple drawers where you can temporarily store items for easy access. And then there are vector registers. These handle multiple data elements at once. Imagine being able to sort your entire desk instead of moving one paper at a time. With these registers, we can juggle numerous pieces of data, which is pivotal for video encoding and decoding. Now, let's break down a simple assembly code snippet. Picture this. We're telling the CPU to store the number 3 in a register, increment it, then decrement it, and finally multiply by 5. It's a bit like cooking, with precise measurements and operations bringing together the right flavors for a finished dish. The result? You're left with 15 in that register, our final dish. Before we wrap up, I want to highlight something meaningful about the community aspect of learning assembly. There are resources, forums, and even Discord servers available to help you on this journey. People share insights, tackle challenges together, and celebrate victories, big and small. So as we close this introduction to assembly language in FFmpeg, think about this. Coding is more than just writing lines of text. It's a form of communication with the machine. It's about efficiency, speed, and ultimately, creating amazing multimedia experiences.